In the early 1970s, humanity cast two silver spears into the infinite dark, Pioneer 10 and 11. They were our first true explorers, the first to navigate the treacherous debris of the asteroid belt, the first to behold the gas giants up close, and the first to achieve the velocity required to leave our sun behind forever. Their mission was a triumph of 20th century engineering, but as they crossed the threshold of the outer solar system, where the sun is little more than a bright star, the data began to whisper something impossible. They were slowing down. It wasn't much, an infinitesimal drag, a negative acceleration of exactly 8.74 times 10 to the negative 10th power meters per second squared. To a layman, it is a rounding error. To a physicist, it was a siren in the silence. It was as if an invisible hand was tugging on our messengers, pulling them back toward home. According to every law of motion we possessed, that hand shouldn't have existed. For 20 years, the Pioneer Anomaly haunted the halls of NASA's Jet Propulsion Laboratory. We checked the math, then we checked it again. We looked for gas leaks, solar wind pressure, even the gravitational pull of unknown Kuiper Belt objects. Nothing fit. We tracked them via the Doppler shift of their radio signals. By measuring the stretch of the waves sent back to Earth, we could calculate their speed to within millimeters per second. The data was undeniable. The probes were roughly 400 kilometers closer to the sun than they should have been after decades of travel. The implications were staggering. If the anomaly was real, it meant our understanding of gravity was incomplete. Were we seeing the first evidence of modified Newtonian dynamics? Was Einstein's general relativity failing at the edge of the system? Or were we moving through a cloud of dark matter that provided a subtle cosmic friction? For a moment, the world of physics held its breath. We were prepared to rewrite the textbooks. The universe rarely gives up its secrets to grand theories alone. Sometimes the answer lies in the mundane. In the early 2010s, a team led by Dr. Slava Turishev at JPL performed a feat of digital archaeology. They recovered decades of forgotten telemetry data from rotting magnetic tapes and reconstructed the Pioneer probes bit by bit in a virtual environment. These were the heart of the craft, nuclear batteries. They fueled the probe by decaying plutonium-238, generating immense heat. Every photon carries momentum. As the back of the large parabolic antenna absorbed and re-radiated that heat, it acted like a microscopic thruster. This was the aha moment. It is a phenomenon known as thermal recoil pressure. The heat bouncing off the back of the dish was pushing the spacecraft backward. It was a force equivalent to the weight of a single grain of sand. But in the frictionless vacuum of the void, that grain of sand, acting over 30 years, was enough to move a mountain. The Pioneer Anomaly wasn't a sign of new physics, but a testament to the precision of the physics we already have. It taught us that at the furthest reaches of our reach, we cannot ignore the smallest details, even the recoil of a light beam. Pioneer 10 and 11 are now silent. They are ghost ships drifting through the interstellar medium at roughly 12 kilometers per second. In about 2 million years, Pioneer 10 will reach the vicinity of the star Aldebaran. They were built to find new worlds, but their greatest gift was a final masterclass in the laws of our own. The universe is a puzzle, one that yields to the most patient observers.